Hello viewers, welcome to my channel. If you haven't yet subscribed to my channel, do subscribe and press the bell icon near the subscribe button so that you get the notifications of my latest videos, and do not forget to like and share the video. So we'll be studying about the continuation of this chapter, light, reflection and refraction, which belongs to the chapter 1 of physics and chapter 10 of NCERT. Our topic for today is sign convention for the reflection by spherical mirrors. So before going for the numericals related to spherical mirrors in physics, we will be following a set of sign conventions. We'll be learning about some sign conventions. So while dealing with this reflection of light by spherical mirrors, we have to follow some set of sign conventions, and those sign conventions are known as new Cartesian sign convention. In this new Cartesian sign convention, the pole of the mirror is taken as the origin. Alright, and the principal axis of the mirror is taken as the x-axis, that is the x-x of the coordinate system. See, you have graph, right? You follow the graph. Even there you have something called the sign convention. You follow a sign convention, right? This is your graph. Here you take the x-axis, x-x, and here is your y-axis, y. This is your y dash, right? Then here this point is your origin, right? This is how we'll be following some kind of sign convention in physics also. In this reflection by the spherical mirrors, even here we have some set of sign conventions. Now, which is the origin? Let me take a concave mirror. This is the concave mirror, curved inwards. The pole of the mirror is taken as the origin. This is the origin over here. Here, pole is the origin, alright. This is the principal axis, right? This is taken as x-x of the coordinate system. This is the x-x. This is the principal axis. Now, let me continue the sign conventions and let me explain in brief. After that, I will draw and show you. Alright. Now, one by one, we'll be seeing the sign conventions. How it should be followed, which is the plus or minus, how we take the distances of the object and of the image and all. So the first sign convention that we are going to follow is that the object, alright, the object is always placed towards the left of the mirror, okay, left of the mirror. The object is always placed to the left of the mirror. That means the light from the object always falls on the mirror from the left hand side. Let this be the mirror, let this be the concave mirror, okay. Here is a pole. So where should my object be placed? Always towards the left of the mirror, okay. A, B, this is the object. That means where does the light come from? From where does the light incident on the mirror? From the left hand side, it incidents on the mirror. Now, same case for convex mirror also. I showed you with the help of a concave mirror. Now, let this be the convex mirror. This is the rough surface of the mirror. Alright, pole. Where should my object be placed? Towards the left. Again, I place the object from over here, and the incident rays, it falls from the left hand side of the mirror. Alright, this was the first sign convention. Second sign convention is that all the distances parallel to the principal axis are measured from pole of the mirror. All distances parallel to the principal axis are measured from where? Are measured from the pole of the mirror. mirror. Okay, now even in your graph system, what do you see? All the distances are measured from this origin, right? This is y dash, x dash, this is x, right? All the distances are measured from the origin. This is 1, 2, 3, etc. And here it's -1. It's measured from the origin. Even over here it's measured from the origin. Now in our sign convention for spherical mirrors, which is the origin? Pole is the origin. So all the distances which are parallel to the principal axis are measured from the pole of the mirror. I take a concave mirror. This is the pole of the mirror, principal axis. Okay, now I take this to be my object. Okay, so I measure it from the pole of the mirror. Say this is 5 centimeter. Okay, or I take some kind of rays that are incidenting on the on the concave mirror. Somewhere the object is over here, or let it be somewhere over here itself. Okay, so that you understand it better. It incidents like this on the mirror. It is parallel to the principal axis. Again you measure it from the pole itself. How much centimeter it is, 10 centimeter or 15 centimeter, whatever centimeter it might be, or whatever the measurement, whatever is parallel to the principal axis, how much of a distance, okay, whatever the distance parallel to the principal axis is measured from the pole. Okay, even if your image is over here, because objects are always towards the left hand side, image can be either left hand side or right hand side, doesn't matter. If it is on the right hand side, again you'll measure it from the pole. Okay, from the pole, because pole is your origin. Now the third sign convention. Third sign convention is all the distances that are measured right of the origin are taken as positive. Okay, all distances right of the origin, they are positive. They are taken as positive sign. Okay, and all the distances left of the origin, negative. Say you take the number line. No need to go for a graph system. I'll take a number line. You all know what is a number line, right? This is the 0. Okay, number line goes on. So I've drawn this arrow. 1, 2, 3 goes on, right? And over here, -1. Here -2, -3 goes on. See, towards the right of this 0, positive numbers, right? And towards the left of the 0, negative numbers. Same ways in your spherical mirror, take this spherical mirror, a concave mirror, pole is the origin. If you take a number line, this is a 0, -1, -2, -3 goes on. Here 1, 2, 3 and it goes on, right? Here this is 0. Let this pole be a 0. Just imagine this pole to be 0. Okay, now distances right of the origin. Which is the origin? Pole. Distances that are right to the pole, taken as positive. Okay, say an object is over here. Okay, I measured it from the pole of the mirror, right? I measure it from the pole of the mirror. Let this be say 3 centimeter, but I shouldn't write 3 centimeter in physics. It should be plus 3 centimeter. It should be considered as, minus 3 centimeter. Since it is towards the left of the origin, it is minus 3 centimeter. I take another object over here. Let this be like 4 centimeter, but where is it? It is towards the right of the origin. So how should I consider it? Positive. Here I should say it is plus 4 centimeter. Always mention the sign plus or minus. Alright, I hope you have understood this. Distances right of the origin are taken as positive. Distances left of the origin are taken as negative. Now, in the first sign convention, I told you that objects are placed where? Towards the left of the mirror, always towards the left. That means object distance is always negative. Object distance is always negative. Okay, never forget this. Then, the fourth sign convention. In the fourth sign convention, we will be seeing that till now we saw parallel to the mirror, whatever distances are parallel to the mirror. In the fourth and fifth, we will be seeing about the perpendicular to the principal axis. What happens when any object or image is perpendicular to the principal axis. Fourth sign convention. Distances that are measured perpendicular to and above the principal axis are taken as positive. Okay. Let this be the spherical mirror. I take a concave mirror again. Pole, principal axis. Okay. And then I take some object. Okay. I will take an object that is perpendicular to this principal axis and it is above the principal axis, like this. See, it is perpendicular 90 degree, plus it is above the principal axis, not below the principal axis, it is above the principal axis. Perpendicular to and above the principal axis. This is taken as positive. This distance, I am not talking about this distance. This distance specifically is taken as positive. Even if it is here, I am talking about this height. Even this is taken as positive. Okay. Now, in the fifth sign convention, I am taking an object or an image that is perpendicular to the principal axis and below the principal axis. Let this be the object. This is the object. I am talking about the height of the object. Since it is perpendicular to the principal axis but below the principal axis, I consider this height to be negative. Similarly, over here, doesn't matter that it is right of the pole, so I should consider it to be positive. No, that is only in terms of this. I am talking about this distance, okay, this distance, the height of the image. This is negative. So these were the 5 sign conventions by spherical mirrors. Let's have a quick recap. Let me go with the concave mirror itself. This is the concave mirror, okay, rough surface. Then this is the pole. Pole is the origin of the mirror. Then I talked about the principal axis. Principal axis is the x dash x of the coordinate system in the spherical mirrors, in this new Cartesian sign convention related to spherical mirrors. This is the x dash x. Then next, all distances parallel to the principal axis are measured from the pole. All distances this way are measured from the pole of the mirror, that means the origin. The third sign convention, we learned that all distances right of the pole, right of the origin are taken as positive. Distances left of the origin are taken as negative. Then fourth sign convention, distances that are perpendicular to and above the principal axis are taken as positive. This height is positive. Even if it is here, this height will be positive. Then if it is below the principal axis, what will the height be? This is negative. Even if it lies over here, this specific height of this will be negative. So these were all the sign convention for the reflection by spherical mirrors. If you have any doubt, do ask me in the comment section, or if you want me to make a video on a particular subject or on a particular topic or on a particular chapter, even that, do mention in the comment section.